Hey y'all! This video is going to be a little bit different from my usual content, as I want this video to function as a guide for new users who are looking to hone in their 3D printers. In the description are timecodes which will section the video into parts for specific calibration steps, so let's not waste any more time and jump right in. First, a little bit of information about calibration. Every printer is slightly different. Small changes in hardware or software can result in different print qualities. Aside from just hardware, ambient conditions are also a huge factor. Humidity, temperature, airflow are all things that you should consider when looking at your printer. While not a filament parameter, it is important to calibrate your machine every time there is a significant change in any ambient conditions. For example, if I had decided to print in my house versus my workshop, it would be very important to PID tune both my bed and hot end, as well as run a bed mesh calibration because of the differences in temperature. Modern printers will actually run a bed calibration before every print as a toggleable option, so this step has even become even easier to abide by. As for the filament calibration itself, it is argued whether it is truly necessary. For me, I don't believe it's a necessity to get successful prints, but I think it is imperative for getting quality prints. Since my channel mainly focuses on the aesthetics of the stuff that I print, I have noticed a clear jump in quality ever since I started calibrating my printers and the filaments. Before I discuss calibration steps, it is important to note that this calibration suite was not invented by me, and most of the steps that I am discussing today are all sourced directly from the... I do not claim to be the inventor of this method. I just really wanted a simple way to categorize my experience with filament calibration, as I didn't see many exhaustive videos when I was looking. This video will be split into two sections, one for general filament calibration, and then a section for A1 specific color calibration. I split these sections due to the wealth of testing I later conducted on color purging for projects that I either have already showed or some that I have yet to release. For this video, I will be using Orca Slicer's calibration suite. However, similar models can be downloaded and implemented in similar ways on other slicers. For example, in Cura Slicer, all of these calibration models and modes are actually plugins. I have tested 3 PLAs, 1 PETG, and 1 RPET on 3 different printers: my SV08, my Bambu A1, and my K1. While I won't mention it in this video, I also calibrated PLA on my modified Ender 3 Pro that uses 2.85mm filament, so this does work on a quote non-new machine. I wanted to start with the SV08 and K1 as they serve as great general examples. I highly recommend using cold white whenever possible for calibration. Cold white shows the most imperfections of all the colors that I have tested. This is a fact that I've also seen corroborated by many other makers that I've talked to. It is very important to see the imperfections, as the whole point of calibration is aiming to correct those imperfections. The 3 PLAs I calibrated were PLA, PLA Silk, and Hyper PLA. There are a ton of different marketing names for PLA: Tough, Pro, Plus, Matte, etc. In my testing, I have found that Hyper PLA is the only variation that requires a separate calibration, although again, your mileage may vary. I believe this is because on a chemical level, Hyper PLA is different from other blends. While exact blend chemistry is a trade secret, I have a few insider connections who have shared some information with me. PLA Silk gets its silky appearance from additions of TPU into the blend. This is why it is recommended that Silk PLA receive a hotter melt temperature and slower print speed. Additionally, PLA Silk will often string easier than regular PLA. Hyper PLA is the same, quote, blend as normal PLA, but the polymer chains are shorter. This makes the plastic weaker, thus it can flow much faster. I report this information because it seemed to pan out that exact way when I calibrated. Normally I print PLA at hottest 220 degrees Celsius, but Silk PLA looked the best at around 225 degrees Celsius, while Hyper PLA looked good even up to 235 degrees Celsius. Speaking of temperature, that is the first recommended test in this calibration suite. To test temperature, I recommend setting the range for testing to the range listed on the packaging for the filament you're testing. For instance, inland filament comes with a little pamphlet that discusses the filament's properties. On each pamphlet, the temperature range is listed. The default unit of change in the slicer is 5 degrees, and I don't personally recommend changing this. A range of 5 degrees is more than precise enough to capture the temperature needed, and does not use that much filament or time. Once you have your desired temperature found, you should change that in the filament profile and save it. I like my profiles to be very orderly, so I name all of them very carefully. Even though filament profiles are saved by printer, not by computer, I still make it a habit to name my profiles for the machine that I tested them on. You can see here that I have my profiles listed as K1, A1, and SV08 in particular. Also, a bit of a side note, but I highly recommend writing down your results or recording them otherwise electronically. Sometimes it is important to look back at your results and make sure you reported the correct numbers. After temperature calibration, flow calibration is next. Flow calibration is split into two phases, macro and micro adjustment. These are listed as Flow 1 and Flow 2. The idea behind this approach is that the larger macro pass will give a ballpark estimate of flow, and the smaller micro pass will hone in that estimate. When doing pass 1, it is recommended to find the largest number that looks quality. If you are between two numbers, say 5 and 0, choose 5 as the number to use. This is because the second pass will start at the higher number and work down to the lower number, thus capturing all within its range. As a side note, this test will also serve as a decent bed level test, as if the bottoms of your flow squares look off, it means your bed adherence is off. Now that you've gotten your numbers, here is how you use them. Pass 1 will take the number you believe is the best and use it in this formula to find the new best number for flow. Once the new flow is calculated, you must change it in the filament profile under flow ratio. Once the new flow is set, you can conduct the second pass. Once the second pass is done, you should repeat the previous calculations to get a final honed-in flow ratio. Change it in your filament profile and save. From here, the extra tests are based off of what you feel is necessary. It is very important to know what you care about as a maker and let that lead what you test for. For me, I don't really print at high speeds, so I don't test much outside of pressure advance and max volumetric flow. For additional testing, I would point you to the Orca wiki for how to conduct those specific tests. For my testing, PA and MFV are the only tests I really needed outside of flow and temp to get really great prints. I did want to add that some people recommend a retraction test. However, I feel that because the temperature tower has those little peaks for retraction testing, I don't often test retraction as a separate parameter. Some people actually recommend that once you do the whole suite, you actually go back and retest temperature again, and that should remove the retraction errors. And if not, then you should go through the suite again to get an even more honed in number. However, in all of my testing, I found that the retraction issues or stringing issues kind of went away immediately as soon as I did the first run through, and I didn't have to do a second run through. But if you ever get to a place where you're having a lot of stringing, that could be something that you could check out. Let's start with pressure advance. Pressure advance is a new technique for printing that aims to solve an issue with the physics of how plastic melts. As the printer moves filament into the nozzle, the diameter of the plastic is usually 1.75 millimeters, but what comes out is much smaller. As this reduction occurs, there is a pressure buildup in the nozzle. This pressure buildup will affect strength and aesthetics when eventually printed. This is what PA aims to fix. For most machines, I recommend the tower method. The tower method prints a small tower where PA is slowly increased until failure. Just like the temp tower, I believe the default values for the tower's creation are perfectly sufficient. Once the tower is printed, you should measure the distance from the bottom of the tower to the first instance of under extrusion. I would highly recommend being conservative with this estimate, as too low a pressure advance value is much better than too high a value. You can see an example of what happens if your value is too high right here. The next step is for Bambu A1 series machines only, so if you don't have one of those machines, feel free to skip to this timecode to move on with the rest of the video. For A1 machines, there is a special cell in the toolhead that will automatically calibrate pressure advance. This option will replace the toggleable option for auto calibration that I mentioned in my A1 review. I would highly recommend calibrating each filament in the slicer, that way you don't have to waste as much filament calibrating each print each time for each color. The way to do this is currently exclusive to Bambu Studio. Move to the Calibration tab and go to the Flow Calibration section. Select Automatic Calibration and select the filament you wish to calibrate. With the AMS Lite, you can calibrate multiple filaments at a time, although I don't really recommend it, as it just makes things a little bit overcomplicated. This is saved on the printer itself and should be selected whenever picking a new filament on the printer's actual screen. This K value will save under the name that you called it in the profile in your slicer. This is why I make it a habit of naming all of my profiles very carefully. Additionally, these will be saved under the category you originally started working with. For example, all of my PLA tests on the A1 started as a copy under the generic PLA settings. Thus, they are listed under generic PLA, same with high-speed PLA or PTG, for instance. The final parameter I test when calibrating filaments is max volumetric flow, or max vol flow, as you'll hear. This is different from the flow we previously calculated, as this is volumetric flow, and the previous flow was a mass flow. The difference is a bit out of the scope of this video. If you're really interested, I would highly recommend checking out and researching the difference for yourself. Just know that these are two different parameters, despite the fact that they are both listed as flows. For this test, again, I feel the defaults are more than serviceable. Same as the PA tower, measure the first layer to which the tower failed and use that in this equation to find the filament-specific max vol flow rate. In all of my testing, the sample failed within the allotted height, with one notable exception. My A1 was actually able to print the entire part without failing, meaning it could handle a large amount of vol flow without failing. If you have any idea why this is, please feel free to leave a comment below, but I feel it's something to do with the design of the A1's hot end. That pretty much wraps up the filament calibration. Now to move on to color tuning. Since I am still very new at multicolor printing, this section will be a tad more specific to the A1 specifically with the AMS Lite. But I'm hoping that there's portions of this that could be better for a general audience and good for anybody that's doing multicolor. Firstly, the easiest way to decrease your filament waste is to just be smart in how you slice your files. If you can, print separate colors on separate beds and assemble after the fact. If that is not possible, or you want to emboss logos on your print, try to emboss only on a few layers at a time. I personally would recommend embossing logos only about one layer deep, both for strength and for reducing filament waste. Here is an example of a print that I did where I embossed the logo through the entire part. Notice how the colors didn't fully meld together, thus the part breaks when you bend it. You can avoid this issue by embossing only on one layer, which makes the parts much stronger. And, as we're hoping to do, avoid using as much filament in waste. The other two easy ways to reduce filament waste are simple but effective. The option purge into support and purge into infill are both really great options for reducing waste, although depending on your model, they may not reduce waste a significant amount. I personally do not print with heavy infill density, so there isn't much volume to purge into. Similarly, I don't often print with supports, so this option doesn't really save me a lot of material. The third option is my personal favorite. If possible, have the color swap be a filament swap at layer. Aside from getting beautiful multicolor prints at a fraction of the waste, this method is also possible on nearly every printer, regardless of multicolor unit support. This technique I actually went into depth in my previous video, but here's a little summary of it. To create this color swap, the process is the same for both an AMS or traditional setup. Once a file is sliced, go to the Preview tab and look at the layer view. In the layer view, scroll through the print to find the layer you want to swap to a different color. Add one layer above, as the color will change after that layer is printed. On the scroll bar on the right, click to bring up the option Per Layer. For traditional printers, click Pause at Layer. This will stop the printer and allow you to manually swap the color by hand. On a multicolor system, such as the AMS, you should choose the option Swap Filament. This option is only available if you have multiple colors set up in the filament section in the left portion of your slicer, and that works for both traditional printers or with an AMS system, as I've found in my testing. One thing I noticed while testing is that if you slice a model and add a color swap at a certain layer, then reslice the file in a new layer height, Orca and Bambu Slicer will automatically calculate a similar relative height to keep the swap at the same plate. But this technique is not possible in all cases, so I have one more method to reduce printer waste. If you've ever done a cold pull of your hot end, you are no doubt familiar with the fact that the molten filament at the end will expand and form a blob in the shape of the nozzle when heated. At this time, if the film is pulled out of the hot end, there is a chance that this blob could get jammed and break off, causing a filament jam. This is why modern multicolor systems such as the AMS or CFS work with a cutting blade in the printer's tool head. When the printer is ready to swap colors, it will cut the filament and retract. The upside of this is it means, hey, there's no clogs. The downside is it wastes a ton of material. The Voron community and Prusa community have been working on the idea of tip shaping for a number of years now. Tip shaping is the idea of specially forming the molten plastic at the end of the nozzle so that it can be fully retracted without blobbing and jamming the extruder. In an ideal case, tip shaping would mean you could have almost zero waste, and your print times would also go down. Currently, Bambu does not offer a way to tip shape officially, and is not something that I've tested. However, there is a way to get close. Thanks to the hard work of this creator, Bambu has added an option to the slicer called Long Retract on Color Swap. This will pull the filament back on color swap before cutting. This can significantly decrease the amount of waste your machine produces. Here is an example of before and after of using this method. You can see a clear reduction in the amount of filament needed to purge between colors. This then can be updated in the flushing volume section of your slicer. As a general rule of thumb, I have found I am able to successfully reduce my flushing volumes by around 60% on nearly all colors I've used with very little bleed. However, if you really want to push these savings, you could calibrate each individual color transition. This calibration is much more in-depth than the previous calibrations, as they need to be done for every single color transition, so I don't really recommend doing this for every single color. Rather, use a few extreme cases and go from there. The way to test this color bleed is with this model in MakerWorld. This user has an excellent video discussing how best to use their model that I would highly recommend checking out, but here is a quick rundown. Add the model to your slicer, change flushing volumes to 0 in all colors, then print. The number on the right will tell you what is the lowest volumetric amount needed to flush between these colors. Make sure that when you test this you have long retract selected, otherwise it will just show you standard numbers with no reduction in the waste. With each color formally calibrated, you can change the numbers in the slicer's flushing volume section. It should be noted that this section must be edited every time the AMS is synced to the system, unless you disable auto calibrate. I plan to push this work further as I want to reduce waste as much as possible, but this is the current best reduction I have achieved without sacrificing reliability. Well, this was a long one, but that about does it for my information about calibration. I want to thank the team for their work in developing this calibration suite, as it has completely transformed my prints since I started using it. Additionally, I also want to thank this user for development of the long retract option in Bambu Studio. As for me, I hope you've learned a lot from what I found in my testing. Please feel free to leave a comment or let me know how this calibration affected your printing. Hopefully it's positive. That being said, I want to thank you all for watching, and I'll see you in the next video. Bye bye!